Hello everybody, and welcome back to another mathematics video. In this video, we'll be looking at the beautiful topic of functions. And at the end of this video, you should be able to do two things. One, you should be able to evaluate functions. And two, you should be able to evaluate composite functions. Now, what exactly is a function? Now, conceptually, when we think about a function, we can think of it as a machine. A machine in which you insert something and it gives you back out something else. So now let's look at our first example. So the question says, given the function f of x is equal to 3x minus 5, determine the value of, let's say we wanted to find f of 2. So in this case, we see the function f of x is equal to 3x minus 5, and x is being replaced with 2. So just like how in the notation, x is replaced by 2, in the function, in the actual function, we'll replace x with 2. So f of 2 will be equal to 3. Instead of multiplied by x, it will be multiplied by 2 minus 5. And 3 times 2 would give me 6. And 6 minus 5 would give me 1. So f of 2 is equal to 1. So all we did, we substituted the value of x, in this case, which was 2, into the function, and that will give us a value of 1. So f of 2 is equal to 1. So we put in something in the function and we got out another number, and that is what functions do. So let's look at another example. Let's say we wanted to find f of negative 3. So f of negative 3, in this case, we're replacing x with negative 3 in the function. So this would be 3 multiplied by negative 3 minus 5. And 3 multiplied by negative 3 would give me a negative 9, subtract 5. So negative 9 subtract 5 would give me a negative 14. So f of negative 3 is equal to negative 14. So let's supplement these two examples with another example to cement the concept of evaluating normal functions. So let's say we wanted to find, let me draw a line to separate. Let's say we wanted to find f of 1 over 3. So of course, we're doing the same thing. We're taking whatever x is being replaced with and we're putting it in the function. So we have a fraction, we'll put the fraction in the function. So this will be equal to 3 multiplied by x. Now instead of x, this x here, we'll put 1 over 3. Subtract 5. So 3 times 1 over 3 would give me 3 over 3, which will simply give me, 3 over 3 will give me 1. So 1 minus 5 would give me a value of negative 4. So f of 1 over 3 would give me a negative 4. So all we are doing, whatever is the function we want to evaluate, we are inputting that into the function, and that will give us another answer. So we put in something and we get out something, and that is what functions do. So let's look at another example. So this example says, given f of x is equal to 2x plus 5 and g of x is equal to 3x minus 4, determine the value of, let's say we wanted to find f g of x. So in this case, we have a composite function. Now, a composite function means we are taking two functions and we're combining them. How are we combining them? We're basically putting one function into the other. So in this case, we want to find fg of x. So what this notation is saying is that we're taking the function g of x and we're putting that function inside of the function f. So how do we do that? In the previous example, we saw that when we wanted to find f of 2, we simply replace x with 2. So in this case, if we want to put g inside the function f, wherever x is in the function, we'll replace it and we'll put the function g of x. So this will give us, we'll take in the function f because we're putting g inside that. So we'll say 2, instead of x, we'll put the function g of x plus 5. So this will simplify and give us 2 multiplied by the function g of x, which is 3x minus 4 plus 5. And we use our knowledge of algebra to simplify this. So this 2 has to be distributed throughout. So this will be 2 times 3x would give me 6x. 2 times negative 4 would give me a negative 8 plus 5. And this will simplify further to give us 6x. Negative 8 plus 5 would give me a negative 3. So fg of x would give me 6x minus 3. So we're taking the function g and we're putting it inside the function f. Whatever function is on the outside, we're putting that inside the inner function. Let's look at another example. Let's say instead of fg of x, we wanted to find gf of x. In this case, we're taking the function f, because the f is the outer function, and we're putting it inside of g, which is the inner function. So this will be, we're taking the function g now, you're writing that, so this will be 3 multiplied by, instead of x, we're replacing it with g of x. Instead of x, we're replacing it with f of x. So f of x would be f of x minus 4. This will further give us 3 multiply, the function f of x is 2x plus 5. So we're putting that in the function. 2x plus 5 minus 4. We use our knowledge of algebra and simplify this. So 3 times 2x would give me 6x. And 3 times 5, positive 5 would give me plus 15 minus 4. And 6x, 15 minus 4 would give me plus 11. So gf of x would give me 6x plus 11. And as we can see, we can see the function fg of x is not the same as the function gf of x. So we need to be careful when we are doing our substitution. We must remember, whatever function is on the outer part, we're putting that function in the inner part. So this question can go on further to ask us another thing. They can ask us to find fg of 2. So let's say we're given the same function, f of x is equal to 2x plus 5 and g of x is equal to 3x minus 4. And we now want to find fg of 2. See, there are 2 ways, probably more, but there are 2 main ways that we can use to take into consideration that we did not just do all the work in the previous 2 examples, and we look at the way, taking that into consideration. So let's look at this question. So fg of 2. So in this case, we're taking the function g of 2 and we're putting it inside the function f. So this will be, we can first find g of 2. So g of 2 would be equal to, we'll use the function g of x. So this will be 3 multiplied by x. Instead of x, we'll say 2. Subtract 4. So 3 multiplied by 2 would give me 6. Subtract 4. 6 subtract 4 would give me 2. So g of 2 is equal to 2 after we work it out. Now this is a coincidence that g of 2 is equal to 2. This is not always the case. So we just need to be careful when we work it out. So g of 2 is equal to 2. So what this is saying, we're taking the value of g of 2, in this case, which is 2, and we're putting that inside the function f. So now this can work out and give us, instead of f of x, we will put what is the value of g of 2, in this case, which is 2. So f of 2 is equal to 2 multiplied by, instead of x, we'll say 2 plus 5. And this will give us 2 2's 4. 4 plus 5 would give me 9. So f of 2 is equal to 9. That is after we're done with our working. And this is one way that we can work this question. So let's look at the other way. So the other way would require us to find fg of x. But because we already found that in the previous example, fg of x, which we found to be 6x minus 3. So we have fg of x is 6x minus 3. We will take this function into consideration and find fg of 2. So fg of 2 would be, so we already have the function fg of x, so we're taking 2 and we're substituting inside of that function that we found. So of course, if you did not do the work and you want to use this approach, you must first find, before you find fg of 2, you must first find fg of x. But because we already found it in the previous example, we not go through that again. So this will be 6, instead of x, 2, subtract 3. As 6 times 2 will give me 12, subtract 3, this will give me 9. So fg of 2 will be equal to 9. And as you can clearly see, it's the same thing like what we found just now. We worked it the other way. So it's just up to preference and how you want to work this. The easier way to do it would be to find g of 2 first and then take that answer and put it inside of f. Or you can find fg of x first, then you go on to find fg of 2. It's up to you. And we'll end off the video with a final example to solidify our understanding of composite function. Let's say we're given h of x is equal to 4x minus 5 and g of x is equal to x minus 4. And we want to find the value or determine the value of hg of negative 3. So let's do this. So we want to find hg of negative 3. So what I will do, I will first find what is g of negative 3. And then I'll take that answer and I'll substitute it inside the function h. So g of negative 3 would be, we see the function g of x is equal to x minus 4. So this would be negative 3 subtract 4. So negative 3 subtract 4 would give me a negative 7. So g of negative 3 is equal to negative 7. So I'm taking this negative 7 and I'm putting it inside the function h, because that is the value of g of negative 3. So I will find h of negative 7. So this will be equal to 4. Instead of x, I will say negative 7 subtract 5. So 4 times negative 7 would give me a negative 28 subtract 5. So negative 28 subtract 5 would give me a negative 33. So h of negative 7 is equal to negative 33. And that is the value of h of negative 3. And that is how we work these kind of composite function questions. Now these questions will typically go for 2 to 3 marks and they are easy marks. It's just up to you now to remember these steps and remember how to do your substitution. And your little knowledge of algebra will guide you through getting these questions correct. So with that being said, that has brought us to the end of this video. See you until next time.